After this video, you should be able to complete the Khan Academy topic Scientific Notation Intro, Arithmetic with Numbers and Scientific Notation, and Scientific Notation Word Problems. So let's get started. All right, scientific notation is a way to write very, very big numbers and very, very small numbers so that you can work with them a little bit easier. So here's what I mean. If I have this number, 3,280,000,000, and I want to write it in scientific notation, what I'm essentially going to do is rewrite it so that I have a number, we're going to call that n, that's between the values of 1 and 9.99999 times 10 to the, we'll call this x power. Okay, and that number is either going to be a positive or negative integer. So what do I mean? So I'm going to rewrite this so that this number here is 3.28, a number between 1 and 9.99. So we're going to call this 3.28 times 10 to the something power. All right, so 10 to the what power? Well, if I multiply this by 10, it's 32.8. If I multiply this by 100, it's 328. So how many zeros do I need to add to this? Well, I need to add 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 3.28 times 10 to the 9th power. This is what's called standard notation, scientific notation. If I needed to go the other way, to convert the other way, I'm going to move this decimal. If this number is positive, this is going to become big. So I'm going to move this decimal 9 places to the right. Okay. If this number is small, I'm going to move the decimal to the left. So let's take a look at this number down here. This is a really, really, really small number. So I want to write this as 5.21 times 10 to the something power. What is that power? We're going to move this decimal 1, 2, 3, 4, 5 places, but this is really small. A negative exponent is a really small number, right? So I have 5.21 times 10 to the negative 5th. Say I want to convert these into standard notation. So this is going to be a really big number. It's positive, so we're going to move the decimal 6 places to the right. So we're going to move it 1, 2, 3, 4, 5, 6, right? We have the decimal here. 1, 2, 3, 4, 5, 6. 10 to the negative 5th, that's a really small number. So we're going to move this decimal to the left 5 times. So we're going to go 1, right? So I have 2, 3, 4. Here was my decimal. I moved it 1 place. 2 place, 3 place, 4 place, 5 place, right? 1, 2, 3, 4, 5. So you have to add those zeros as placeholders. All right, so now we want to perform some arithmetic with scientific notation. So let's say we had to multiply these. First thing I would do is I have this in standard notation and this in scientific. So I want to turn them both into scientific. So I'm going to turn this into 9.4 times 10 to the 2nd power times 2 times 10 to the 3rd power. And we know that multiplication is commutative. We can do it in any order we want. So I'm going to put the digits next to each other, and I'm going to put the powers of 10 next to each other. So I have 9.4 times 2, that's 18.8. 10 to the 2nd and 10 to the 3rd, well, just like with exponents, I have 2 10s and 3 10s, so now I have 5 10s. Well, this is not in proper scientific notation. This number needs to be between 1 and 9.99999. So I'm going to make this smaller, 1.88. So if I make this smaller to maintain my value, I need to make this bigger by a factor of 10. I made this smaller by a factor of 10, so I have to make this bigger by a factor of 10 to maintain its value. Okay. Now we have division. Again, I'm going to rewrite this in scientific notation, so they're both in the same type of format. So I'm going to move this 1, 2, 3, 4 places. 6.5 times 10 to the negative fourth. And on the bottom, I've got 5 times 10 to the negative 2 power. So again, I'm going to go ahead and divide. So 5 goes into 6.5. We divide. 6.5 divided by 5 is 1.3. And then what do you do when we have bases that are the same and we're dividing? We subtract these. So this is going to be times 10 to the negative 4 minus a negative 2. Right? I have negative 4 minus a negative 2. It's going to be negative 2. All right, adding and subtracting. So this is a little bit harder. If we think about adding and subtracting, we always need to line up our place value. And right now, if we wrote this whole thing out, this would be 1, 2, 3, 4, 5, and that would be, I would have 3 zeros, an 8, and a 5. They don't line up, so I can't just subtract 4.9 minus 5.8 because they're not in the same place value. So what I need to do is I need to rewrite one of these so that the exponents match. So I'm going to go ahead and turn this into 49, make this bigger. So I'm going to make that smaller. Now they have the same place value. So I'm going to do 49 minus 5.8, and that's 43.2 times 10 to the fourth. Okay, this is not in proper scientific notation, so I need to make this smaller, 4.32, smaller by a factor of 10, so I have to make this bigger by a factor of 10 to maintain balance. And now we have an addition problem, and again, our place values are not the same, so I'm going to go ahead and make this a 10 to the fourth. So if I make this smaller, I have to make this number bigger by a factor of 10. Bigger, so make that smaller. So if I add 54 and 6.7, that's 60.7. Okay, we maintain our place value. So I need to make this smaller and make this bigger to maintain our value. And we're done.